Assalamu alaikum. My name is Shahzeeb Hassan and my registration number is 21T67. This is my lab report number 5 of DSP being submitted to Sir Jameel. I have performed all my tasks on MATLAB online and pasted the screenshots here. So starting with the task 1. First of all, I have defined my new function as my DFT of x. Then I given the value of n and defined the value to y. Then I used for loop as for k is equal to 0, and then I am doing indexing as n equal to -1. Then I again used one more for loop as you can see. Then I created one more function of my idfty. Then again I assigned value to n and x and used two for loops. Here I am giving value to our main signal as x equal to 2, 3, 4 and 5. Then I called my function of my DFT of x display. Then I use display command DFT coefficient to display our coefficients. Then I am again calling the second function my IDFT y and then again using display command. Here I am using the second signal x is equal to 2, 5, 8, 9 and the same procedure is being used as first I am calling the first function of my DFT and again I am calling second function of my IDFT y. Here I am giving value to the third signal as 1, 2, 3, 2, 3, 4, 1, 2. Then following the same procedure as calling the first function and then second function. Here is our fourth signal as x equal to 1, 0, -1, -2, 0, 1, 1, and 2, and the same procedure will be followed. So these are the output of the task 1. X when we gave signal values 2, 3, 4, 5. These are the DFT coefficients. These are the tasks. This is of 2, 5, 8, 9 output 2. This is of 1, 2, 3, 2, 3, 4, 1, 2 output, and this is the output of 1, 0, -1, -2, 0, 1, and 2. Now moving, this is the next output as 1, 0, -1, 2, 0, 1, and 2. Now moving on to task 2. Here I am giving values to the different signals as x1 to x11. Then I used figure command. Then I used a built-in command of FFT, which is fast Fourier transform, and title as x9 is equal to n is equal to 32. This is our output where n samples, number of samples are 32. Now moving on to the task 3. Here I am giving the value to signal as x is equal to 1, 2, 3, 4 and taking its fast Fourier transform. And then I am finding the real parts, and here I am finding the imaginary parts, and here finding the absolute parts. This is task 4 where I am giving values to different signals and then calling them differently as fast Fourier transform, and then finding their absolute part, angle and imaginary parts. This is the code of the following. This is the output of our code where this is the magnitude spectrum, the second one is the phase spectrum, and third one is the power spectrum. Thank you. This was on today's lab. Allah Hafiz.